Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over an example on how to find the roots of a quadratic equation by factoring. Alright, so in this problem, we're given a polynomial function and we are asked to find the zeros of the given equation. Now, if you're given a polynomial function and you're asked to find the zeros, it is the same thing as finding the roots of the related quadratic function or quadratic equation in standard form. So we want to find the zeros of this polynomial function. What we'll do is we'll set the function equal to 0. Now this related quadratic equation can be solved in multiple ways. In this tutorial, we're going to be going over how to solve this equation using the factoring by grouping or the AC method. In order to do that, first of all, we need to determine what A, B, and C are. So A is 2, B is -5, and C is -3. So to determine this, you simply look at the coefficient of the term with the highest degree, x squared, that's A, and then B is the coefficient of x, which is -5, and the constant is C. Now that we have A, B, C, we're going to set up our x game, or the AC diamond. So we have AC on top and B on the bottom. Now the objective of this game is to express this quadratic trinomial into a quadratic involving 4 terms so that we can factor by grouping. So what is AC in this situation? Since A is 2 and C is -3, we simply multiply both of them together to get -6 for AC, and B is -5. Now this is how you play the game. You ask yourself, what are two numbers that multiply to give you -6 and add to give you -5? So you can list all the multiples of 6, 1, 6, and 2, 3, and see which combination altering the signs can give you a product of -6 and a sum of -5. So if you try 1 and -6, that works perfectly. Okay? If you test it, 1 minus 6 is -5, and 1 times -6 is -6. Now, these two numbers that we came up with, 1 and -6, we're going to replace the middle term, -5, with those two numbers. Okay, so this now becomes 2x squared plus x minus 6x minus 3 equals 0. Now we have 4 terms, and we can factor by grouping. Now to assist us to maintain a good visual cue on what's going on, we're going to partition our factors down the center to the left of the sign. Okay? Now we're going to factor by grouping. To accomplish this, we'll look at the first 2 terms to the left of the partition, and we'll ask ourselves, what is the greatest common factor of the 2 terms? So what is the GCF of 2x squared and x? The GCF is x. So what we'll do is we'll factor out x from the first 2 terms. And if we factor out x, it is as though we're dividing 2x squared and x by x. Okay? So if I factor out x from 2x squared, I'll have 2x. And if I factor out x from x, I'll have 1. You can always multiply to check to see if your answer is correct. X times 2x is 2x squared, that's good. And x times 1 is x, perfect. Now let's shift our attention to the right side of the partition. Now we're going to apply the same procedure. We're going to ask ourselves, what is the GCF of the 2 terms? What is the greatest common factor of -6 and -3? The greatest common factor is -3. One thing to keep in mind is whatever number you factor, you always retain the sign that's to the right of the partition. So if this were plus, the GCF will have a positive sign also. Now we factor out -3 from these 2 terms. It's as though we're dividing these 2 terms by -3. If we do that, we'll end up with 2x plus 1. Okay? If you check, negative 3x times negative 3 times 2x is negative 6. And negative 3 times 1 is negative 3. So that's perfect. At this step, when you factor out the GCFs, you should pause and do a quick check. If you factor by grouping correctly, the quantities in parentheses must always be identical. Is that the case here? It certainly is. If you look at the two quantities in the parentheses, they are identical. That means that we factored correctly. Okay? Now we are going to proceed to the next step in our factorization procedure. The two identical terms in the parentheses, the 2x plus 1 and the 2x plus 1, will factor it out. 2x plus 1. And the GCFs that we factored out earlier in blue, x and negative 3, will be grouped in their own parentheses. Okay? Of course, we're still setting this equal to 0. To finish this off, we're going to use the zero product property. Since the product of these two quantities are equal to 0, then we can set both of them equal to 0. And we just solve these two resulting equations to get the solutions, the roots, to our quadratic equation, which are the zeros of the related quadratic function f of x. To solve the first one, this is we can do this easily by subtracting 1 from both sides and dividing by 2. Okay? Let's go ahead and do that. Subtract 1 from both sides. That yields 2x equals negative 1. And then you proceed to divide both sides by 2 to isolate x. And then we have x equals negative 1/2. Now that is the first root of the quadratic function, or the first zero of the polynomial function. Now let's shift our attention to the second equation. We'll just simply add 3 to both sides, and we have x equals 3. And there goes your second root. Now, for the polynomial function, these roots are the zeros. Okay, so we can write them in a set notation. The zeros are negative 1/2 and 3. Now, can we check to see if our results are correct? We certainly can. Now, how do we check to see if these two are in fact the zeros of this polynomial function? Well, to do the check, we'll simply plug in these values into the function and see if we get what? We see if we get 0, because they're called what? They're called zeros, okay? So let's test the first 0, negative 1/2. Now, what do you get when you evaluate the function at negative 1/2? If we get 0, that means that negative 1/2 is in fact a 0. Okay, let's go ahead and substitute negative 1/2 for the x's in this polynomial function. That results in 2 times negative 1/2 squared minus 5 times negative 1/2 minus 3. Okay, all we're doing is simply evaluating the function at the first 0. Now, to simplify this, we're going to use the order of operations. Please excuse my dear Aunt Sally, okay? We're going to deal with the exponents first, multiplication next, and then addition and subtraction from left to right last. All right, so what is negative 1/2 squared? You have to be careful with that. Remember, when you're squaring, you square both the numerator and the denominator, okay? So we're going to have 2 over 1 times negative square is positive 1. Negative 1 square, sorry, is positive 1. And then when you square 2, you get 4. And then in this case right here, minus times minus is a plus. And then 5 times 1 is 5. And then you have the 2 at the bottom, okay? And then the minus 3 over there. Now, how do we solve this resulting expression with the fractions? Let's go ahead and simplify it first. 2 over 1 times 1 over 4 is 2 over 4, plus 5 over 2 minus 3. Let's express 3 as a fraction. That makes it easy for us to find the LCD. Now, in order to combine these fractions, we need to ensure that all your denominators are the same. But in this case, your denominators are different. We have 4, 2, and 1. So we have to convert all three into the LCD of what? Of 4, 2, and 1. And the smallest number that they can all evenly go into the LCD is 4. So let's go ahead and convert all the denominators to 4 if it's not already the case. Alright, so since 2 over 4 already has a denominator of 4, we'll leave it alone. In order to make 5 over 2 to have a denominator of 4, we have to multiply the numerator and the denominator by 2. Okay? 3 over 1, in order to make the denominator 4, we have to multiply both numerator and denominator by 4. If we carry out the arithmetic procedures, we end up with 2 over 4 plus 10 over 1 minus 12 over 4. If you combine this, you have 2 plus 10 is 12 minus 12, you end up with 0. And if you divide 0 by 4, your final answer is 0. Okay? Now, since this procedure resulted in 0, what does that tell us? It tells us that negative 1/2 is in fact a 0 of the polynomial function. Now let's shift gears to the second root. How do we check that one? Well, we just simply plug in 3 into all the x's. We want to find f of 3. So plug in 3 into all the x's in this polynomial function. You have 2 times 3 squared minus 5 times 3 minus 3. We're going to apply the order of operations again. We're going to square the 3 to get 9, and we can even multiply 5 and 3 to get 15 also. So we have 2 times 9 minus 15 minus 3. Now remember, in your order of operations, in this term right here, 2 times 3 squared, remember you have to square, do the exponent first before you multiply. Okay, that is why we have 2 times 9. Okay, let's simplify further. 2 times 9 is 18. Negative 15 minus 3 is negative 18. 18 minus 18 is 0. That is perfect. That shows that 3 is also a 0. Now, since we plugged in both of our solutions into the original function and ended up with 0, that means that negative 1/2 and 3 are in fact zeros of our polynomial function. Thanks so much for taking the time to watch this presentation. Feel free to give us a thumbs up to support our tutorials. And don't forget to subscribe for updates to other great tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.